Hello, dear students. Let us to discuss chapter number 6, that is electromagnetic induction. So the marks allotted for this chapter 8. So there are very simple questions. Easily we'll get minimum 6 to 7 marks on these topics if you prepare very well. And the number of questions are also very less, but marks is 8. Okay, let us to discuss some terms in these topics. Electromagnetic induction. So the question may be asked many times, what is electromagnetic induction? Okay, the phenomenon in which electric current is generated by varying magnetic field is called electromagnetic induction. Okay, note on this very important term. The question is, what is electromagnetic induction? So answer for this one is the phenomenon in which electric current is generated by varying magnetic fields is called electromagnetic induction. Okay. The phenomenon of electromagnetic induction is used in the working of power generator, dynamo, transformer, etc. So it means these devices, that is power generator, dynamo, transformer, all works on this phenomenon. Next one is phenomenon of electromagnetic induction was first demonstrated by Michael Faraday. Okay, let us to discuss with the help of experiment to study electromagnetic induction. And before going to that, one more term, magnetic flux. Already all of you know electric flux. Flux means field into area, and here also the magnetic flux is magnetic field into area. It is the dot product of field and area, or field area into cos theta. What is this theta? Theta is the angle between the direction of the field and normal to the area. Okay, ನೀವು ಯಾವ ಏರಿಯಾನ ಚೂಸ್ ಮಾಡ್ತಿರಲ್ಲ ಆ ಏರಿಯಾಗೆ ಒಂದು ನಾರ್ಮಲ್ ಲೈನನ್ನು ಡ್ರಾ ಮಾಡಬೇಕು. ಇನ್ನು ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ಗೆ ಆ ನಾರ್ಮಲ್ ಲೈನ್ಗೆ ಇರುವಂಥ ಆ್ಯಂಗಲ್ ಥೀಟಾ. ಸಪೋಸ್ ಥೀಟಾ is 0, then we are getting the flux is more, that is maximum. And if theta is 90 degree, whatever may be the field and area, we are not getting any flux. It is very, very important for future, remember. So this will helps how that generator will work. ಜನರೇಟರ್ ಹೇಗೆ ವರ್ಕ್ ಮಾಡುತ್ತೆ ಅನ್ಲಿಕ್ಕೆ ತಿಳ್ಕೊಳ್ಳಿಕ್ಕೆ ಇದು ಟರ್ಮು ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್. ಏನು? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್, ಫೀಲ್ಡ್, ಏರಿಯಾ, ಕಾಸ್ ಥೀಟಾ, ರಿಮೆಂಬರ್. ಓಕೆ, ಸೊ the SI unit of magnetic flux, Weber. Okay, so the unit of magnetic field is Tesla, and the unit of area is meter square. So hence we can write Tesla meter square or Tesla square meter. Okay, capital T small m square hingu baribodu. Okay, so idu question exam dalli bandide. write the SI unit of magnetic flux, and it is scalar quantity. Flux is scalar quantity. Field and area are vector, and their dot product. See, their dot product up to vector is a scalar. Okay. So now we have to discuss that experimental study of Faraday's and Henry. See, this experiment is consisting of just ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟದಲ್ಲಿ ಏನಿದೆ ಅಂದರೆ ಒಂದು ಕಾಯಿಲ್ ಇದೆ. The ends of the coils are connected to the galvanometer. What is this galvanometer? Galvanometer is a current sensitive device. Means it can detect very small current. ಇಲ್ಲಿ ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಇದೆ. ಮ್ಯಾಗ್ನೆಟ್ ಏನು ಕೊಡುತ್ತೆ ನಮಗೆ? That gives the magnetic field. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಈ ಕಾಯಿಲ್ಗೆ ಲಿಂಕ್ ಆದಾಗ, okay, we are getting the flux. The flux is field area into cos theta. Okay, so now flux that will link, flux is linked with the coil. ಹಾಗಾದರೆ just by varying the position of magnet the position ಅನ್ನು change ಮಾಡೋಣ. So definitely the field or the flux which links with the coil change ಆಗುತ್ತೆ. Okay, so whenever there is a change in the magnetic flux which is linked with the coil or circuit, then EMF will be generated or current will be flowing through the galvanometer, and this phenomenon itself called as the electromagnetic induction. ಇದಕ್ಕೆ electromagnetic induction ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ಹಾಗಾದರೆ just ನೋಡಿ the explanation of this experiment. When the north pole of a bar magnet is pushed towards the coil, the pointer in the galvanometer deflects, indicating the presence of electric current in the coil. The galvanometer does not show any deflection when the magnet and coil are stationary. When the coil or when the magnet is pulled away from the coil, the galvanometer shows deflection in the opposite direction. ನೀವು ಮ್ಯಾಗ್ನೆಟನ್ನು ಕಾಯಿಲ್ ಕಡೆಗೆ ತರೋ ಮುಂದೆ ಡೆಫ್ಲೆಕ್ಷನ್ ಯಾವ ಕಡೆ ಆಗಿತ್ತಲ್ಲ, ಮ್ಯಾಗ್ನೆಟನ್ನು ಕಾಯಿಲ್ನಿಂದ ದೂರ ತಗೊಂಡು ಹೋಗೋ ಮುಂದೆ, ರಿವರ್ಸ್ ತಗೊಂಡು ಹೋಗೋ ಮುಂದೆ, ಬ್ಯಾಕ್ ತಗೊಂಡು ಹೋಗೋ ಮುಂದೆ ಏನಾಗತ್ತೆ, that will again showing the deflection in opposite direction. ನೀವು ಕಾಯಿಲನ್ನು ಅಥವಾ ಮ್ಯಾಗ್ನೆಟನ್ನು ಕಾಯಿಲ್ ಕಡೆಗೆ ಪುಷ್ ಮಾಡಿದ್ರಿ ಅಂದರೆ ಡೆಫ್ಲೆಕ್ಷನ್ ಆಗತ್ತೆ. ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಕಮ್ಸ್ ಟು ಝೀರೋ. ರಿಮೆಂಬರ್, ಅಲ್ಲೇ ಉಳಿಯೋದಿಲ್ಲ. ಅಂದರೆ ಮ್ಯಾಗ್ನೆಟ್ ಯಾವಾಗ ಮೂವ್ ಆಗ್ತಾ ಇರತ್ತೆ ಅಲ್ಲ, ಅವಾಗ ಮಾತ್ರ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರತ್ತೆ. ಮ್ಯಾಗ್ನೆಟನ್ನು ಅಲ್ಲಿಂದ ತೊಗೊಂಡು ಹೋಗೋ ಮುಂದೆ ಅಗೇನ್ ಇಟ್ ಈಸ್ ಶೋಯಿಂಗ್ ಡೆಫ್ಲೆಕ್ಷನ್. ಅಂದರೆ ಆ ಟೈಮ್ನಾಗ ಮತ್ತೆ ಅಗೇನ್ ಆ ಸರ್ಕ್ಯೂಟ್ ಒಳಗಡೆ ಏನಾಗತ್ತೆ, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಬಟ್ ಇನ್ ರಿವರ್ಸ್ direction. Okay, so this is very important experiment, and even the experiment is very simple also. Okay, so now we have to discuss the law of electromagnetic induction. Just we have discussed, that is the magnitude of the induced EMF in a circuit is equal to the time rate of change of magnetic flux through the circuit. Mathematically, the induced EMF is E equal to minus d phi by dt. Here phi is magnetic. It means the rate of change of magnetic flux. Okay. The negative sign indicates that induced EMF or current opposes the change in flux. Flux ಅನ್ನು ಚೇಂಜ್ ಮಾಡಲಿಕ್ಕೆ ಏನು ಮಾಡ್ತಾ ಇರುತ್ತೆ, ಕಾಯಿಲ್ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಅಂದರೆ ಮ್ಯಾಗ್ನೆಟನ್ನು ನೀವು ಕಾಯಿಲ್ ಕಡೆಗೆ ತರಲಿಕ್ಕೆ ಹೋದ್ರಿ ಅಂದ್ರೂ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಹೌದಾ? ಅದನ್ನು ರಿಟರ್ನ್ ಬ್ಯಾಕ್ ತೊಗೊಂಡು ಹೋಗ್ಲಿಕ್ಕೆ ಹೋದ್ರೂ ಸಹಿತ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಇಟ್ ಈಸ್ ಆಲ್ವೇಸ್ ಅಪೋಸಿಂಗ್. ಓಕೆ. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದ್ಯಾಟ್ ಇಟ್ ಈಸ್ ನೆಗೆಟಿವ್. ಓಕೆ. ಇನ್ನು ನೋಡಿ, ಈ ಲೆನ್ಸ್ ಲಾ ಏನು ಹೇಳುತ್ತೆ ಅಂದರೆ, the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. ಏನು ಹೇಳ್ತಾ ಇದೆ? The polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. Lenz's law is based on the law of conservation of energy. Just ನೋಡಿ, if the north pole of a bar magnet is moved towards a coil, the direction of induced current in the side facing the coil anti-clockwise. If the north pole of a magnet is moved away from the direction of induced currents in the side facing the coil in clockwise, cleared? Okay. See, both, if the north pole is pushed towards the coil, okay, the direction of induced current in the side facing the coil anti-clockwise. Okay, ಅದನ್ನು ರಿಟರ್ನ್ ತಗೊಳ್ಳೋ ಮುಂದೆ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಪ್ರೂವ್ಸ್ ದಿ ಲಾ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎನರ್ಜಿ. ಅಂದರೆ ಎನರ್ಜಿ neither to be created nor destroyed in this case also, remember. Okay, so this is very important law, and in next class we have to discuss the motional EMF. It means when the coil or when a rod which is moved in a magnetic field, how much EMF will be induced in it, that we can discuss in the next class. Okay, try this carefully. Okay, thank you. Note down it.